Welcome to my presentation regarding my project on visual search engine called Viz-iT. In this presentation, I will go through the main concept of the visual search engine application and how it will be useful in our daily lives. How my chosen neural network model works, how the whole application should and expect it to work, and finally a demonstration of the application running in real time. First, I will introduce you to the main concept of this project. The main concept of this visual search engine project is to use an image as a search term. So first, segment that image into one or more objects. Recognize those objects and then use the object classification to get the object class. Then use that object class as the image as the search query. The motivation for the visual search engine is to provide the end user vetted, trusted and valuable content to their searches based on the given image as the search term query. This project will offer many applications such as identifying objects within a given image that the user did not know about, learning about new objects and helping user find information on the internet in terms of the image being the search query. As a result, this project will be really ideal and time efficient to use rather than identifying the object yourself and manually typing the search term into the search engine. Now we get to the fun part, my desired neural network model. From the title you can see I have chosen Mask RCN as my neural network model. How does Mask RCN work? Well, Mask RCN model is divided into two parts. First is region proposal network to propose candidate objects bounding boxes, and second is binary mask classifier to generate masks for every classes. So first, images run through the CNN to generate the feature map. Region proposal network uses a CNN to generate a multiple region of interest using the lightweighted binary classifier. It does this using 9 anchor boxes over the image. The classifier returns the object or non-object score. Non-max suppression is applied to anchors with high objectness score. Then the region of interest aligns network output, multiple bounding boxes rather than a single definite, wrap them into a fixed dimension. The wrapped matter features are then fed into fully connected layers to make classification using COCO and boundary boxes. Prediction is further refined using the recursion model. Wrapped features are also fed into mask classifier, which consists of 2 CNNs to output a binary mask for each region of interest. Mask classifier allows the network to generate masks for every classes without competition among classes. And that's it. That's how Mask RCN model works. So how does the application work? First, the application is initialized to the home page. In the home page, you have 2 options. In the bottom navigation bar is either a live button option or a upload option. The upload option, you have 2 options, either to choose from a camera where you could just use the camera to take a picture in person, or use the photo library to upload a photo that is already existing in the device. Then the image is sent to the Flutter API control where it requests where it's requested by the REST API. Then the REST API sends the model to the test Mask RCN model. Then we receive the response of the predicted results, then saves that predicted into the backend or the REST API. Then the REST API sends the image as a base64 to be rendered into the front end. Similarly, with live page, it's the same thing, but with live, you just click the live button, then it does the same thing, but it does it every 5 seconds. Every 0.5 seconds. So every 0.5 seconds, the Flutter control requests or sends and requests the REST API to get the neural network results and the results are also in base-64 for to be rendered in the front end. Now let's get to the fun part. It's time for demonstration. So for front end, I'm using Flutter, which can be compiled either in Android and or iOS. Then for the REST API, I'm using Python Django. I'm going to be testing on a real device, so I'm connecting to my laptop's IP address. So that's why the allowed host is that. And when I configure it, it's also run in that in port 8000. Similarly, in my global, I have it declared as that because I'm running on a real device. If it's just running on emulator on your computer, just use the normal localhost here. So I want to test the neural network model to see if it works or not. So I'm going to turn a variable, so test the neural network model to true, to see what the program basically does. I'm not going to go to the code itself in that much detail, but I will go to the main part. So this is the backend, right? So let me go to neural network, and in the model section I have the mask RCN here. Then that's the model. So that does all the training and the testing purposes. So all the calculations I have mentioned in the my report and what I said at the start of how the mask RCN works, I'm just applied that into the code. I just implemented that here. Then to visualize it, so the visualizing thing, that puts it all into a graph. Uses a graph to put it on top. So this displays the image. Then all of that. So let's just run it now. So now I'm just running both the application backend and frontend. Okay, these are all the 80 classes that I have trained. So if an object is not within this class, it won't be recognized. That's why in my future work I have mentioned that I need to test, I need to have more than 80 classes and train more object, but these are just the broad objects. Like for example, like car, I just said car, it could be like a BMW, an Audi, or anything like the brand of the car with that, or anything like that, or like the model of the car as well. Similarly with a cell phone, just a cell phone, it could be an iPhone, Samsung. It's not specific. So both application has been compiled, and as you can see, I have as you can see, I have it running on a real device where I will be screen recording to put it on the demonstration. So first I will upload an image from my library and show it being tested. Let me choose this horse picture, person with the horse. Oh. So now I'm actually testing the model since I put it as since I used the boolean here, right? So now I'm testing the neural model as true, so now it's going to test all of it. So this will shows the anchor boxes, the intersection over the union, the non-max suppression, the detection, the mask, all of that. So here are some of the calculations. So here are the objects I have declared. So 7 detection, person, horse, horse, person. Just waiting for the response to say everything's been successful. So now it's gonna, yep. So I got 200, so it's been uploaded, got the result and the data. So as you can see, the results in the front end with the button on top, and if I go to mask, it shows the mask result as well. But before I get started with that, let's go into the diagram and discuss that in detail. So this shows the prediction. So there's a person there, person, horse, horse. Then this is with the non-max suppression, so it removes the multiple boxes, right, and reduces it. This is the area of the region of interest before refinement, so it just does so many boxes before it's being refined. Then after refinement, it's simplified. The detection of the non-maximum suppression. Here is the mask of each of the objects. And this is the prediction when you combine all of that by the intersection over union. this is the graph, like this is to get the coordinates. So when we're drawing the boxes or the mask, it's done by this coordinates basically. That's using the eye image to get different like binary masks of the image. And here's a histogram of the detection. And here's the image classification diagram. So you can see it's like mostly here, here, in the initial values and the secondary value. So y1 and x1 is the starting horizontal value, and y1 is the starting vertical value, and y2 and x2 is the end horizontal. So you create a box from here to here, and that's how it draws this box. So now getting to the application, I have these plots. So if I click this button here, it should give me a horse. So it searches the horse, give me the information regarding that, and I could close it. And it opens. And if I click the person, it shows me the person. So this is a bottom sheet that shows all of this. And here the mask, you can see the percentage that the person is 99% detected, like the accuracy of that person being detected is 99% by the neural network. Similarly, the horse as well is 99%. Similarly, you can see everything is over like 90%, because the lowest one is 92%, which is the person here, but I still recognized it as a person, and 92 is still high. Let me test another photo to show you this in about with loads of people and like loads of objects. So in this picture, you can see there's one massive airplane in the background and loads of people like running around, loads of it. Does it detect all of it? Let's see. So here you can see the image is being sent, and the prediction is happening. So it's going to do the test again. After this, I'm going to stop the debugging mode, the testing of the neural network, to prevent like the latency. So similarly, it does all of that. I'm not going to talk about this much more because it's the same, like same as the previous one, but it just looks different. But on the image and the front end, you can see like detects basically every single person there, and one airplane at the back. So if I click the airplane thing, so it goes to the airplane. So it searches it correctly. It searches the object class that it detects in the search model, and here any one of them is a person, right? So now what I'm gonna do is basically turn the test neural network option off. So by doing is to do that is just put this as false. Then let me just run the model again. Not on the model, I mean the backend. Oh yeah, let me go and show you the Django side as well. So this is what the network is. So it gets all the routes. So these are all the routes. One is the upload, the post method upload, the get method to get the result from the neural network, and another get method to get the data, which is the object class, the x-axis, and the y-axis as well to draw the box, or to draw the boundary box, and to find the midpoint to put my interactive button. So now let me test the camera feature in the same upload as well. So let me open camera, and there's a fruit basket here. Let me take a picture of that. Use photo. Then I have the option to crop as well. Let me crop this to show that it works. So I'm just cropping into that. I'm just zooming into that photo, and let me apply that. So it's been detected. See? So it detected all the apples except one apple there next to the banana and the apple. So it detected everything as apple and banana. So if I click banana, it will show me information regarding banana. And then similarly, if I click Apple, it will show me information about Apple. But in this case, it shows the Apple company since it's the most relevant compared to the fruit apple by the PageRank method, because it just shows whichever site is more relevant or whichever object is more relevant and ranks that in order. Let me take another photo. Let me take it with this. So as you can see, it detects multiple objects. I will show you where it detects just one, or does it detect one object accurately. So this is another test with multiple objects, but with laptops, monitors, and keyboards. So it detects that. So it detects there's a laptop, and it detects the keyboard on the laptop as a keyboard. Then it detects the monitor, all the bottles on my table, and the keyboard. So if I click keyboard, it will show me results for keyboard. You can scroll and search as a normal search. Yeah, then if I click that, that's a TV, so it recognizes it as a TV. Then if I click bottles, it just takes me to bottle. Now let me test it with just one object to show that it works. Let me zoom in. It just takes that. So it works with different number of pages, just the amount of data objects. So it doesn't simplify into or narrow it down. It's just a broader object. So see, it declares that for some reason it detects this as a suitcase, which is wrong because it's not enough data set. So it detects the keyboard. So all of that. Now let's go to live. So here we go. This is the live. It detects the keyboard, detects the TV, the keyboard. But if I have a PlayStation here, it doesn't detect it, or the watch or anything, because it's not in the mouse. But it detects the mouse. Then if I click the laptop, it takes me to the laptop thing. It's still running in the background because this is just the bottom, so that's good. So it detects when you're turning around, when you recognize something new, you can still turn to it and recognize it. For example, here is a bowl. It recognizes a bowl. So the bowl. There we go. And that's it. This is my application. Yes, I would mention this, but also I need to test false positive and false negative. So let me just take a picture and show you. So if I take a picture of this black screen here, that should give me false negative, where there's no object being recognized. So no instant to be displayed. So I'm just waiting for the object. So in the front end, I will get the image back, and with the text over it, with a black outline in the background. If it's a white image, you can see it since I took a black image to confirm there's no object. So that's the thing. An improvement for this was mentioned in my future work in my report. Now let me test for a false positive. So let me take a picture. Here's a PlayStation 5. Here's a PlayStation 5, you can see, but let me take a close up. You can still see the Sony logo and stuff. But it should detect, I think it would detect something else because of the shape of it or something. It's just lack of objects and the size of the data set that I'm training. See, it recognizes something, but it's not a PlayStation 5. It's a parking meter, apparently. The shape of that arc is a parking meter and a refrigerator. So this is apparently a refrigerator. And that's a parking meter, apparently. So this is a false positive since it's detected something, but it's not accurate. That's it. That's the demonstration of my application running in real time. And thank you for watching and listening. Thank you. I really appreciate it.